Okay, let's look at some problem solving here. It says, first off, where it says dv, direct variation, I run at a speed of 20 feet per second and run 40 feet farther in the same amount of time than Chad, who has run 17 feet per second. Find the distance each of us has traveled. Okay, so down here the distance is feet, and then there's two answers here. So then my answers, I have feet and I've got seconds. Okay, so I assign the x variable to the seconds and the y variable to the feet, and then my rate of change looks something like feet per second. Now in the problem, I've got a couple of feet per second, so I've got 20 feet per second. 40's not, just says 40 feet, doesn't say it's every single second. And then this one here is 17 feet per second. So there happens to be two, that's because there's two people at different rates, so that would require me to make two lines. Okay, so it's going to be 20 and 17. But direct variation means as the x's start at 0, which we know they do, your y is also going to start at 0, which makes sense because if these guys don't run for any seconds, they're not going to run for any feet. Now you're like, well, what about the 40? Yeah, that's at the end after they stop running. Okay, is the 40. The 40 has nothing to do with when they start. They're going to start same place, same time, I think. Okay, so what that means is we can use some proportions for this problem, but I'm going to need to do some thinking here, because if I go put my x on bottom and then my y, my feet on top, I'm going to have some problems solving this because I don't have anything I could put in for seconds. I mean, none of these are seconds amounts. Okay, if you just kind of visualize that, it's not going to work. So you need to get rid of those labels, and we need to use a different technique. Okay, now for this technique to make sense, you need to go to this other piece of paper that you have. And we're going to run some a test here. Okay. Let's say a guy drives 300 miles at 50 miles per hour, and every hour is 50 miles. So I want to know how many hours he's driven. Again, he's driven 300 miles, and he's done 50 miles every hour. So you got 50, that'd be 1 hour. 2 hours is 100, 3 is 150, 4 is 200, 5 is 256. So it's 6 hours, but you could have easily got that by taking the number of miles traveled and dividing it by the speed, and that's 6. Okay, now right here you've got 540 divided by 90, it'd be the same thing, and that's 6 as well. So what we have is these two cars, they traveled for the same amount of time, but their distances were different and their speeds were different. Okay, so why were these able to end up equal? The times ended up equal, they both ended up at 6 hours. Well, that's because when I took the distance divided by speed, I got 6, and here I took the distance traveled divided by speed, and I got 6. So the times are the same because the distances divided by the speed gave me equal quotients. Okay, so remember that. So in this problem, it says that they traveled for the same amount of time. Okay, so the times are the same. That would mean that if I take the distance traveled by each car divided by the speed, they're also going to be the same. So I put distance, speed, distance, speed. Now you can get rid of your speeds because you know what they were. You know you had 20 and 17. So we replaced the s variables entirely. But the d's I need to keep because I don't know the distance that either car traveled, and nobody traveled 40 feet. It says one traveled 40 feet further than the other. That doesn't mean one of your cars traveled 40 feet, just that one did 40 feet further than the other. It's like if a guy's 2 inches taller than another guy, you don't say the guy's actually 2 inches tall. No. So we don't know the speeds, but we know that this one here, this faster guy right here, the 20 feet per second, we know he ran 40 feet further. So I don't put 40. Instead, what I put is a plus 40 behind that D. Okay, so now I have A, B, C, and D, and we're going to have to use the cross products. So I know that A times B, D plus 40 multiplied by 17 is going to equal D times 20. Okay, so let's drop our equals, circle it, drop it, cover your variables. You don't have any minuses, you're not going to. And then draw your rainbows. I need 2 over here and 1 over here. So 17 times 1D is 17D, and 17 times 40 is 680. 1D times 20 is 20D. So I box my D's up, and they're on opposite sides, so we need to pick one. Let's pick the 17. So let's subtract 17D. So I'm going to get 3 times D over here, and I'm going to get 680 over here. So then I'm going to divide by 3. So I take 680 divided by 3, and I get a decimal, but I'm going to round to the nearest whole number, so it'd be 227. So this guy traveled 227 feet. Now to find the other guy's feet, it's really easy. You know that this guy now went 227 feet at a speed of 17 feet per second. To find this guy's distance, you just add 40 onto it. So I'm going to add 40, and that's going to be 267. Okay. All right, next problem. 2 cars travel for the same amount of time. One car travels at a speed of 40 miles per hour. The other car travels at a speed of 60 miles per hour. The faster car ends the day 225 miles ahead of the other car. Calculate the distance each car traveled. So I'm trying to find the miles. So there's 2 of those. So I've got miles, and then the other unit would be the time unit, which is hours. So X is going to be the hours and Y is going to be the miles. So when I set up my rate of change, I've got miles per hour. Okay, miles per hour, we got this guy at 40 and then this guy at 60. So I put 40 and 60, and the 225 isn't every single hour. Okay, that's when they got done. One ended up 22 ahead of the other. Okay, so the M's, we got 40 and we got 60. Okay, with direct variation, we know that we don't have any miles to start with, and it's not 225. Nobody drove 225 before the hours. That's impossible. Okay, so I'm going to use ratios. Again, if I try to set up the miles and the hours, if I try to use the X and Y units, I'm in trouble because I don't have any hour quantities. They're all miles per hour and miles. Okay, so we need to use another piece of information in the problem. The fact that they went for the same amount of time. So the times for the cars were equal that they drove. Well, if the times are equal, then I know that when I take their distances traveled divided by the speed they travel, those are going to be equal as well. Okay, so for my speeds, I know I've got 40 and 60. Now, you want to keep the D's here because you don't want to fall into the trap of putting that 225 in for one of your D's, because nobody traveled 225 actual miles. One traveled 225 further than the other, but that doesn't mean they traveled 225 miles. But we know this faster car traveled further, and he traveled further by 225. Okay, so now I can use my ABCD cross products method. Okay, so I'm going to take A, which is D, times B, which is 60, and then I know that's equal to D plus 225 times 40. Okay, so I just have one rainbow here. I'm going to have 2 on the other side. So 1D times 60 is 60D, and then 40 times 1D is 40D, and then 40 times 225 is going to be 9,000, so plus 9,000. Okay, so we got these two D amounts, and they're on opposite sides, so we're going to pick the 40 to get rid of. Okay, so on this side I've got 20 times D, and on the other side I've got 9,000. Okay, then I'm going to divide by 20, divide by 20. So I'm going to take 9,000 divided by 20, and that's going to be 450. So this one car, that's the answer for one. Now to find the other, you just add the 275, and that tells you what your other one was. So that's going to be 450, no, 225, 275, where'd I get that? It's 225. So 450 plus 225 is going to be 675. So those are the mileage traveled by each car. Okay. Okay, I'll go over a couple more. Two cars travel for the same amount of time. One car travels at an average speed of 50 miles per hour, while another car traveled at an average speed of 60 miles per hour. The faster car travels 40 miles further than the slower car. Find the distance each car travels. So miles is the unit for my answer, but there's two of them I need to find because there's two cars. So I've got miles and hours. So X is the hours, Y is the miles. So to write the rate of change properly, it's always Y per X, miles per hour. So we got 50 miles per hour and 60 miles per hour. So I got those two. So I'm going to make two lines. And dV it says, so remember that. So my M's I know are 50 and 60. And they both begin at 0 because it's a direct variation. Okay, so that means we go to our ratios. So again, just like on the last problem, I will attempt to put the X unit in the denominator and the Y unit in the numerator. But when I look at the problem, I can see that's not really going to get the job done because I don't really have any hours quantities. That's just that's not feasible. Okay, but again, they went for the same amount of time, so the times that the carts traveled are equal. So if the times are equal, that means when you take the distance divided by the speed for each car, that's going to be equal to. So my speeds, I know I've got 50 and 60, but I don't know either distance. Again, it's not 40, okay? Just one went 40 further, and it'd be this one that went 40 further, so I just make that D plus 40 as opposed to that one that's just D. A, B, C, D. And I use my cross products. So A times B, you're going to get D times 60. D plus 40, and then 50. Then 1, 1. Okay, you need two rainbows over. So 50 times 1D is 50D, and then 50 times 40 is 2,000. So I subtract 50D from each side, and I get 10D equals 2,000. Then I'm going to divide by 10. 2,000 divided by 10 is 200. So the first car, the slower car, went 200 miles, and then if we add 40, that ends up at 240. Okay, and then our last one. Two cars travel for equal amounts of time. One car travels at an average speed of 80 miles per hour, while the other car travels at an average speed of 60 miles per hour. Faster car travels 100 miles further than the slower car. What distance did each car travel? So the miles, blank, and blank. So I've got miles, and then there's a time unit. It says per hour, so hours would be the other one. So that's X, that's Y. So per miles per hour, and we know we have 80 miles per hour and 60 miles per hour. 100 is not a miles per hour. Okay, so the M's, we've got 80 and we've got 60. 0 hours, we're not going to have any miles, okay. I know ratios. I know if I do miles over hours, you know, like with the Y on top, the X on bottom, that's a good way to start, but it's not going to work because I don't have any hours quantities. So we have to use another piece of information. That's the fact that they travel for equal amounts of time. So the times for each car are the same. So that means when I take the distance divided by the speed for each car, that's also the same. Okay, so my speeds, I know we got 80 and I know we've got 60. Okay, these D's I'm going to leave in there. But I know that this faster one traveled 100 further. So A, B, C, D. Okay, so I'm going to take A times B over here, and then C times D over here. Make sure you drop your equals, put ones in front of your D's, then go to your rainbow. 60 times 1D is 60D. 60 times 100 is 6,000, and then we're going to have 80D over here. So the D's end up on opposite sides, so we need to subtract 60D, get it out of there. Okay, so I've got 6,000 and then 20D. So to divide by 20, so I take 6,000 divided by 20, and that gives me 300. Okay, so this guy did 300. Now, if the other guy did 100 more, that takes him to 400.